right. Let's get my glove on here. You can see that I've been working on rocks, but we're going to talk a little bit about other stuff today. Do a little YouTube dance, like, comment, subscribe, all of that. And let me get in here and get the stream started. Where'd it go? Come on. Come on, where's my... Is that it? I think that's it. That's not it. There it is. Okay, found it. All right, here we are. You got started up. No, Katrina, you are not in the wrong place. I am just running a little bit behind because I've gotten sucked into a lot of Twitter drama over this shit. Anyway, as I have already mentioned on the recording, but not quite mentioned in the stream, we're going to talk a little bit about AI art. So the first thing I'm going to do is I'm going to pull up a brand new document so I got something to work with. A lot of people are annoyed about these new AI art programs, and it seems like nobody really understands how they work. So I'm going to kind of go over that. And most importantly, every computer program consists of basically three elements. And those three elements are input, a process, and an output. Now, in this particular case, the input is a whole bunch of images. And the process is to convert all of these images into a machine learning database, or what we call a checkpoint. Now this model, this database is a model of all of the information that has come in here. And basically, machine learning, well, I haven't worked in it for over 15 years. Machine learning is still based on something that we call a neural network, or NN for short. A neural network is like a phase spectrum Fourier transform. Your individual frequency buckets are vectors, and each of those vectors has a magnitude and a phase angle that precisely but non-uniquely identify a parameter solution within the problem space. Absolutely nobody understands a fucking thing I just said, but don't worry. I'm going to go into a bit more detail here and simplify things. So let's say that you're trying to teach your neural network what red is. What you have to do is you have to say red, you have to give it something red. And it goes, okay, and it puts the red thing over here in its white suit. White suit, left-hand pocket. And now once it's done that, it sets the vector. It changes this vector and it says, okay, this is the magnitude and angle of that vector to identify where my red stuff is. So then you give it more red stuff. You say, here's red stuff, and here's some red stuff, and here's some red stuff. And every time you give it red stuff, it goes, okay, and it puts it up here, and it tries to put it near the red stuff that it's already got. And as it places this stuff, every time it places new red stuff, it finds the middle of all the red stuff and it points that vector right at the middle. So when you say, hey, give me something red, it reaches in here, and what you're doing is when you give it that thing and you say, I'm looking for something red, you're telling it which vector to use. And it then precisely but non-uniquely locates a red item. It locates a parameter solution within the problem space. The problem space is like everywhere that it can possibly have stuff. It could have like blue things over here. It could have books over here. It could have bicycles up here. There could be any number of things in here. And for each of those, it would have a different bucket. Like it would have a blue vector that points in the middle of all the blue things. And it would have a book vector that points in the middle of the books, and a bicycle vector that points in the middle of all the bicycles. And all of these things are just individually kept track of. You know, it's kind of like, it's like a box, okay? It's like you have a box. So the system has a box, and you say, here's a red thing, and it grabs a box off the shelf, like box number 42. And it says, okay, I'm going to put my red things in box number 42. And it makes a note, box number 42 is where the red things are. And then it throws all the red things into the box. You give it the red thing, it goes, okay, red thing goes in box number 42. So when you ask for a red thing, it will precisely locate box number 42. There's only one box number 42, and it's going to take a red thing out of the box. But the red things in the box are not unique. There are any number of things in the box, and it could pull out any one of them. You don't know which red thing it's going to pull out. Now, the problem with neural networks is they're kind of dumb, because as you might guess, it would sure be more convenient if a red book could be in both the space with the red things and the space with the books. But in a standard neural network, that's not an easy thing to do, which is where you move to what we call a learning neural network. And a learning neural network moves the groups around to be next to things that they frequently come in contact with. And you might think, well, you know, how useful is this? So, for example, you're putting red books into a database. You have one axis that's like book, and this is how much of a book is this thing. If it's a whole lot of book, then it would be all the way up here. And if it's not a book at all, it would be way down here. And then on another axis, you would have red. And the more red something is, the farther it would be out here. And if it's not red at all, it would be in here. So you've got how red something is and how much of a book something is, and all your red books are up here, okay? Now that's a standard dual Cartesian coordinate system. And human beings don't have difficulty dealing with a dual Cartesian coordinate system. You learn how to do this in 4th or 5th grade, okay? In fact, in high school, you probably learned to deal with 3-dimensional Cartesian coordinate systems. And if you work really hard, you can even get a handle, just like a conceptual model of a 4th-dimensional coordinate system. But here's the thing about computers. Computers can handle dozens or even hundreds of dimensions. It's insane. There's no physical representation to what they can put together. It all exists in this mathematical space that the human brain is just incapable of comprehending. The neural network is basically a model of how the human brain works, or at least of how we thought the human brain worked in the 1980s when it was developed. But the learning neural network starts to really kind of lean in to all of the capabilities of computers that human beings just don't have. And it provides all of this capability to put stuff into the network and then pull it out and have things that are similar, and we would never have thought they were similar. We would never have said, you know, this thing is like that thing. But the computer goes, yeah, they still are. They're like each other. These two things are alike. And the computers are really good at that. And that brought us to, eventually, the deep learning neural network. Because up till now, the neural network and the learning neural network, human beings had to take stuff and give it to the computer, and we had to tell the computer very specifically, I'm teaching you what red means. I'm teaching you what book means. I'm teaching you what bicycle means. I'm teaching you what blue means. And you have you had to individually train all of the vectors, and as each one got trained, it started to go, oh, I get what red is. Okay, here's a red book. Now you can understand what a red book is. Here's a red bicycle, so you can understand what a red bicycle is. And the computer could figure that out. But it had to know what red was first, and it had to know what a bicycle was first, or it just couldn't handle anything. A deep learning neural network doesn't need to know shit. Because essentially the way the deep learning network works is you hand it something and you give it the most detailed explanation you can. And it goes, well, I don't know what the fuck to do with this. And it just holds on to it. But then when you give it something else with this big, long, fuck you description of ultimate complexity, it looks at that and it goes, wait a minute, I see some of the same stuff in these. Okay, so I'm going to put them kind of near each other. And the computer will figure out over time, just as you throw stuff into it. And you just throw the stuff in, you go, this, if you look at this real close, it'll teach you these 47 things. And as you throw more and more stuff in there, the computer will figure out what those 47 things are. It will figure out how to recognize them. And this, all of this, when you put it together, is this is how a search engine works. When you go to Google, or for that matter, when you go to Google, when you go to Bing, obviously, but when you go to YouTube, and when you go to Twitter, and when you go to Facebook, this is how the algorithm works, okay? The algorithm is constantly collecting what we call a compound vector, all right? And at Google or Bing, what you do is you type that compound vector in. It's the same way Stable Diffusion works. You type in your prompt and it works off of that, okay? But typing it in is just one way to do it. YouTube and Twitter and Facebook and all of these algorithmically driven social media, what they do is they look at the stuff that you do. They look at the things that you like. They look at the things you comment on. They look at the things you click through to look at more closely. They look at which comments you read. They look at what you comment on. They look at the content of your comments. They look at the content of comments that you thumbs up or thumbs down. They look at all of this stuff. And from all of the stuff that you do, they generate a compound vector that says, this is what you're interested in right now. And when they show you what's in your feed, when YouTube shows you your recommendations, when Twitter shows you your timeline, when Facebook shows you your feed, whatever they do, they use what you've done on the site to figure out what they're going to put in front of you. Now, the difference is, this is basically what we call a lookup engine, okay? It grabs the stuff out of the database in a list, and it puts that stuff in front of you exactly as it is. It's the exact same stuff, okay? What's different about AI art is a different kind of engine. It's a generation engine. And that generation engine doesn't give you the list of stuff. It still gets the list of stuff. It gets the list of stuff that's similar to what you said, but instead of delivering that list and letting you pick which one you want, it takes all that shit and smashes it together, and it delivers a brand new thing that has never been seen before that is similar to all of those things. Okay? This is what freaks people out. And one of the things that really kind of gets me on this, it's important to understand this database right here, it's beyond the comprehension of a human being. You need a machine to interpret it. And even with the machine, it's beyond the human capacity to make any real sense of. Okay? So people get the idea that inside of here, that inside of this database, you have all of the stuff, and it's just there all by itself to be pulled out. And it can be pulled out, okay? But the way that you pull it out is like nearly impossible. And a generation engine doesn't need to. It doesn't need to pull that out. So this database, the model that comes with all of your AI art, it doesn't actually have the input art in it. And this is patently obvious when you think about it, because there are 2.3 billion images that went into that model. 2.3 billion. And over here, this right here, it's 10 gigs. It's 10 gigabytes. It cannot possibly store all of this stuff. It's just not possible to store all of that unmodified data. This is petabytes of data. It's like millions of gigabytes, and this is only 10. That data isn't in here. It's vectors and differences and diffusion parameters. It doesn't have your actual stuff in there. Now, there's an exception to this, and that exception is something that you can see in a lookup engine as well. If you go to Google and you type a really fucked up, weird query, if you put a very specific compound vector into Google, the list that comes back will have exactly one thing on it. Exactly one thing. There is nothing else in the world that is like this thing. This is the only thing in the world that is like what you just typed in. And if you do that with the generation engine, okay, it's going to make you something that is similar to all of the things that are like the thing you matched with your compound vector. But it's only one thing. So it's just going to make you something that's almost identical to that one thing. That's where you get artists that are coming out and they're saying, I got it to generate something that is very nearly my piece of work. Well, you told it to generate your work. You told it specifically to generate exactly your work. That doesn't happen normally. You have to do it on purpose. Which leads us to why all the artists are mad. The artists are mad because out of these 2.3 billion images, nobody ever asked their permission. They never gave their consent. They haven't been compensated. They haven't even been credited for their work. It was just taken and tossed into this engine, and they had nothing to say about it. And they feel like their rights have been violated. And you know what? I hear you. I really do. I really do hear you on that, and I understand you feel like you've been wronged. Because what's going on here is your art has been taken away from you, and it's been put into a database that other people can use, and the people who put it in the database are making money off of it. And that doesn't feel fair. Well, unfortunately, Blake Field tried to sue Google for this exact thing in 2006. Remember I said this is basically Google? The lookup process? This part up here, where you have all of the issues, that's in Google too. That's all connected there. And when Blake Field came in and he said, hey, Google took my stuff off of my website and it put it in their database cache, and they put ads up in front of it and they made money, and they're violating my copyright. Can you guess what happened? Can you guess? Can you guess what the court said? The courts told Blake Field to fuck all the way off, is what they said. Now, the legal arguments for this you probably don't care about, but what it comes down to is this. When you put images on the internet, there's a way that when you put those images there, that you could say, machines cannot look at my data. It's the robots.txt file. In addition, if you don't want anybody to save copies of your data, you could send a no cache header. If you're not doing that, the courts have already ruled that your work can be taken and used as the input to a process like this, provided they're not explicitly profiting from your work. And they're not. When the artists get together into a class action suit, which is probably not going to happen, and the reason it's probably not going to happen is that an attorney is going to look at them, and it's going to look at Field v. Google, and he's going to say, nah, I don't want to do this case. You go on, find another lawyer who will tell you to find another attorney to prosecute this case, because the precedent is this is okay. This is legal. I'm not saying it's right. I'm not saying it's morally okay, all right? But it's legal. Which brings us to the question of actually using the generation engine. If you use the generation engine to produce something that is very, very similar to somebody else's art, it is your job to check that. you're supposed to look at that. You know you're working from an engine that uses other people's work. And because you know you're working with an engine that uses other people's work, anything you generate might be somebody else's work. It's possible. You might have oh God, what do they call it? You might have Google sniped somebody. Just purely by accident. You might have put in a compound vector that leads specifically to somebody else's work. So it's your job to take whatever you pull out of an AI art bot. It's your job to take that and run it through an image search and make sure you're not just stealing somebody's stuff. And if it looks like you are, just play it safe. Change your prompt a little bit, It's not that important. So anyway, that's where all of that fits together. And there are a number of people that are complaining and saying that the AI art companies are monetizing their work. And no, they're not, because I want to clarify something here. The checkpoint database here, and the machine learning tool, and the generation engine, these are free from Stable Diffusion. Stable Diffusion has given these away. You can have them, okay? None of this is charged for. The only thing Stability AI is charging for is if you want to run the generation engine on their faster machines. If you run it yourself on your machine, it's free. It costs nothing. So my recommendation is, number one, don't pay Stability AI money to use their machines. Run it on your own machine, okay? And that's a much better choice. And that way you at the very least are not financially supporting anybody that's making the artists mad, But as far as actually using Stable Diffusion, yeah, I'm going to use it mostly to generate reference, and occasionally just to play with. Actually, let me grab some stuff that I pulled out of Stable Diffusion. Now I've been working with stuff, and I've been going, hey, can you generate me pictures of Gargura? And sometimes it does okay, and other times not so much. Like, what is this? I don't know what this is supposed to be. It's kind of creepy and disturbing. And yeah, that's the sort of thing that I'm doing, is just I'm working from, let me grab these were actually generated directly from an image, and that image is this one. This is what I started with, and Stable Diffusion came up with this. Some of it's okay, I guess, and then there's these. I guess these aren't bad. I do kind of like some of what it's doing with the eyes, and it is kind of getting a picture going on. I like that. That one looks like Gura. I like the mouse shape on that. That's kind of funny. But I'm mostly playing around and figuring out what the system thinks of concepts. I'm really fascinated by just seeing what it thinks of concepts, and trying to locate like what does Stable Diffusion think is disturbing, and I think it's pretty much nailed that. And then you've got the question of, hey, what does it think is creepy? And you get this collection of stuff. I like this. This is kind of neat. And then there's like what's scary, what's spooky. I was messing around. I put the entire poem Ozymandias by Lord Byron. Two vast and trunkless legs of stone stand in the desert. And it doesn't seem to understand broken. It doesn't seem to understand that. Now, this one right here, this is the only one where it seems to get. It seems to grasp that that it's just the legs, and the rest of it's broken off. It doesn't seem to understand that in the rest. It's got all of this stuff. And some of this is just really fucking cool looking. It's some really neat looking stuff. I love just the look of that right there. That little castle up in the sky. But all of this stuff that I'm running through it, I'm mostly looking to see what it understands. Like I said, show me a broken obelisk. None of these obelisks are broken. I said, well, maybe it doesn't really understand broken. Let's try a shattered obelisk. None of these obelisks are shattered. Maybe this one, it's got some cracks in it. But yeah, I don't see it understanding broken or shattered, and it's not picking up on all of the bits and pieces. But I am messing around with it and doing some interesting stuff. And most importantly, I'm not trying to duplicate anybody else's art. I'm not even trying to build my own art. I'm just trying to go, hey, what do you think this looks like? What is the Gestalt opinion on what's creepy and what's scary and stuff like that? You know, like I did scary. I should have here's scary. This is what it decided was scary. I don't know what she's supposed to be saying here. She's just like babbling something. But yeah, this is what it thinks scary is. A lot of sharp teeth. I think sharp teeth are important. A lot of red eyes. And of course I went through, and if you're familiar with the Loab creepypasta that's going around, I messed around with that. I didn't get much of anywhere. Did I save the, doesn't look like I did. I actually came out when I tried to run the prompt that is supposed to give you the Loab cryptid. What I actually got was what looked like a kind of, it was a little vignette that started off with a man and a woman embracing in a field, and then it was the man and a woman getting married, and a man and a woman kissing, and then there was a brook in the forest, and a door, and then there was a couple with 2 kids. And it seems to have constructed a little narrative there, and that kind of relates to something I think is important about AI as well. The human brain really likes to find patterns in things, and the little story that I saw in those 6 pictures, well, that's a real story, but it's my story. The machine didn't tell me that story. I told me that story. This is just what the machine came up with. It thought these things were similar to one another for some reason. I don't know why it thought the babbling brook and the door were close to each other, but you can always put together a story. You start off, you go, what is alike about all of these things? And if you find something that doesn't fit, your brain switches gears from finding the pattern to what they call thematic apperception. And your brain tries to tell a story about it. And I successfully told myself a story about it, but the computer wasn't telling me that story. People are going around all over the place, and they seem to think that the computers are on the verge of becoming sentient. Computers are on the verge of becoming intelligent. As somebody who actually knows how this shit works, I'm just mystified at how you can look at this stuff and not recognize it for what it is. You're trying to make sense of something that doesn't make sense to you. That makes sense to the computer. The computer can see similarities you can't see. But your inability to make sense of those doesn't make the computer smart. It doesn't make it intelligent. This is all memory. It's just memory and similarity. And while that's largely what the human brain does, The machine has no volition. It has no agency. It can't do the things people are saying it's doing. It's just not capable of it. Now, a lot of people would say that I'm just old and jaded and I don't recognize how terribly dangerous artificial generalized intelligence is. We're not going to see artificial generalized intelligence in your lifetime. We're probably not going to see it in your children's lifetime or your grandchildren's. Indeed, I don't think we're ever going to see it at all. I just don't think it's going to happen. But yeah, that's what I had to say about AI art and how that all fits together. And it's been like half an hour, so let's close out this terrible flow chart of stuff, and let's draw some rocks. Now, I tweeted about something earlier this week, and the thing that I tweeted about was, you know what? Let's pull up a new thingy. So let's get ourselves a new layer. In fact, let's get ourselves 2 new layers. Okay, so let's start down here, and we'll go. I'm gonna go kind of bluish, and we want to go large, and we want to go pretty soft. And let's use pen pressure for opacity. So, okay, so let's just kind of rough in a field over here. And anyway, kind of the thing that I was talking about earlier this week, sort of rough in a little grass field here, is I've seen a sort of 2-axis formation in how people draw rocks. So this kind of 2-axis formation I've got here, let's just sort of do that, and then we'll pull up the blender and we'll just kind of blend a bit. Just kind of like so. There we go. But that 2-axis thing is, you've got people that say, freehand your shape. Okay, now we want to do the pen pressure thing. Let's set our hardness back up. Rocks are hard. You got people that say, rough in the shape freehand, okay? And you've got people that say, no. Use the lasso to rough in your shape. Okay, well, you know, there's that. Those are kind of the 2 things that you look at. And then you have the people that, once your initial shape is roughed in, okay, you got your freehand, you got your lasso people. There are people that want you to start with your shadows, and then you go in and you say, well, here are my highlights over here. Here's some midtones over here. And you just kind of blend those together and get yourself a smoother look, get yourself a better impression of what you want, which I'm not doing a very good job of here, but and you got people that say start with your shadows and then move to your highlights, and then you've got people that are like, no. Start with your highlights. Oh, that's not the brush. Start with your highlights, and then move to your midtones, put your midtones in, and then put your shadows. And then, of course, you know, you blend. which is not working well because of the green underneath of everything. But you got people that say start with your highlights. You got people that say start with your shadows. Now, what I've had best luck with so far is I'm really doing pretty well with using the lasso and starting with the shadows. Because starting with the shadows, if I then come over here and go, okay, and we're going to move to a soft brush. If I go, now here's my highlights here. Let's work with pen pressure for opacity. I can kind of rough that in, and then I can move that up a little bit and go, well, let's have a highlight, and I'll jump in here, and then I can take the blender, just sort of, and it's blending the green in again. I don't know why it's blending the green from underneath of that. How do I stop it from doing that? I don't want it to blend the green in. Let's try turning that off. Maybe that'll fix it. Yeah, there we go. So you get kind of this sort of thing going on, and then you can actually, because you're working with a very soft brush down here, you can do these little sort of things to kind of give the rock some character. Just sort of highlight here. And you sort of soften that up. And you can get a reasonably good result on like a soft-edged rock like that, which is sort of the thing that I've been going for and I haven't been doing too well on. But, you know, now we turn on that kind of background there. You still got the green coming through on that. Huh. It's because this isn't fully opaque is what it is. I'm pretty sure. That's probably the issue. But yeah, that's the situation that I'm looking with here, is to start with your shadows and then move to the highlights. Hold on, I'll blow my nose. And there we go. All right. But starting with the shadows and moving to the highlights has actually worked better for me, and I really do like the lasso method, because you could sort of you can kind of rough something in, and this is the same kind of thing that we did before on a previous rock excursion. But if I start, oops, I forgot to go back to brush. If I start with the full blown, why is that not, there we go. If I go with hardness, and if I start with the shadows here, like so, I go all the way across and I put all of that in, and now I come to the midtones here, and I go back again to my lasso tool, and with this I go through and I go, here's where I want to highlight there, and there's another highlight there, here's one here, here's one in this area, I'm holding down Shift to actually add these elements in there. And I'm going to lock the transparency on this level so that I don't go outside of the bounds of the rock. So I do that right there, and I've got some semblance of a form to this. And when I remove that, now we've got kind of a form to it. And now I can sort of freehand, and I can go, okay, let's come up here to kind of a desaturated highlight, and we'll just kind of go through there. Just kind of catch just the edges here. Really get that sort of rim light thing going on. And pull that in there. And that actually looks horrible. You know, it's, I don't know, blend that shit together. Just kind of, let's drop that down. And I'm going to go hard on that. Not too hard. We'll get kind of a neat swoopy look to it. I really don't like it now that it's softened up. I think it looked better with the sharp edges, but this has its own sort of charm to it. I'm not horrified by it. It's not terrible. Let's take layer 2 and we'll clip to the layer below. And since we're clipping to the layer below, I'm going to take this layer here and I'm going to why isn't that fully opaque? Opacity's 100 there. Yeah, the whole thing I was going for here was to Okay, I'm not sure what to do here. Trying to figure out how to fix this. Let's duplicate this layer. Turn that layer off. And then on this layer underneath of it, right here, we've still got Okay, so we've still got that little bit of green there, but let me grab some of that and we'll back off from that. Really not sure what to do about that green in there. That's something I fucked up and shouldn't have done. No, whatever. Let me grab that. And we'll take this over to our shitscape. Oh, pasting it. Holy shit, that really is like... That is not opaque at all. Holy crap. I can see right through this shit. So let me selection from layer, create selection, and we'll create a new layer underneath of it, and we'll take that layer and we'll go, hey, here's the mid-tone color here. Let's fill that in. Wow, why is that? Is the opacity still got the pen pressure? No. Size? No. Hardness is back up. And that we should merge down. I can take that down to around here. And now I'll to move layer. Holy crap, what is going on with this? Huh. If I turn that off, and I just... Why is that see-through? What is going on with this? Have I turned something on that I shouldn't have? Opacity, 100, blending mode is normal. Color jitter, anti-aliasing, brush shape, brush tip, spraying effect, stroke, texture, watercolor edge, nope, erase, nope, correction. Snapping, that's fine. Starting and ending, anti-overflow. I don't know what's going on here. Ink. Wow. It will literally not allow me to get full opacity there. Okay, then we turn that back on. Merge it down. And go back to move layer. Holy crap, what? What? I do not understand what is going on here. Yeah, see, that's still not... That is still not 100% opaque. I don't know why not. It's the selection, I think. Wow, this is weird behavior. I don't know what is going on with this. Anyway, we're at 51 minutes. I'm gonna have to figure this out so I can avoid doing this in the future. I think it's that I've been messing too much with opacity or something. All right. But yeah, I'm going to go ahead and call it there. Thanks for showing up, as always. Do the little YouTube dance, like, comment, subscribe, hit the little notify icon, all that shit. Hope this was helpful. Join us again next week on Sketch Weekly. And yeah, okay, bye.